Here we have a chemical equation. This is one of the reactions that you did in the lab last class. And it may have some things that look totally different to you. Probably this bit right here. And in chemistry, those are things that tell you about the substance in the reaction, what state it was in, that sort of thing. For instance, AQ stands for aqueous, which a lot of kids think is the same thing as liquid, and it's not quite. Aqueous in the chemistry sense means that the solid was dissolved in water. Okay, silver nitrate is a whitish crystal that was not in your lab. But what I did was I put silver nitrate in water, dissolved it, then put in the little dropper bottles for you. So what you had was dissolved silver nitrate, or what chemists call aqueous. The G stands for gas, which means that in the reaction, this is actually in the gaseous state. There are some reactions where water is in the liquid state in the reaction. There are other times that water has to be in the vapor state for it to work. The S stands for solid, which we see here. Okay, so when you went to clean off your little plastic sheet last time, the little scum left behind, that was solid. Okay, so silver iodide was that substance. And the cursive L stands for liquid, and these are things that truly are in the liquid state at room temperature. Like I said, water could be in the liquid state. Hydrogen peroxide that we saw in the one demo with the yeast that I popped the little glowing splint back on fire with, that's a liquid chemical. Okay, so those are examples of how it would be different from aqueous. The L is cursive because if you did this, it might look like a 1. So we don't use print L's to stand for liquid. Now, the next part I think should make perfect sense. That's a verb. If we change this to produce, that's also a verb. And that should tell you something about where they are. Okay? This side of the bracket, or this side of the arrow, these are the reactants. These are the things that we mix together that are supposed to react. If there's going to be a reaction, those are the things that are going to do it. On the other side, to the right of the arrow, these are the products, because these are the things that were produced in the chemical reaction. So reactants are the things you mix together. They're always to the left of the arrow. The products are what you made, and they're to the right of the arrow. If this was a recipe, the reactants are the ingredients. The product is what you made, like chocolate chip cookies. Now, there are lots of other symbols that you might see in a chemical equation. So I'll let you write these down for a moment. All right, CO2 is a gas. We saw that in bubbles on some other reactions. It's the typical one that we had with baking soda and vinegar. And where do bubbles go? Right, they go up. So this is a shorter version, I guess, if considering that. So if you see a reaction and one of the products is hydrogen gas and it does that, that's telling you that it's hydrogen as a gas, which is pretty darn rare to get hydrogen as any other state. Okay, and now since we have typing, we can do all those cool little arrow symbols and that kind of thing in different directions, as opposed to doing another subscript with parentheses and a G. These three are conditions. And they are always over the yield arrow. The arrow that separates the reactants from the products. Okay, the triangle means heat. Sometimes instead of a triangle, they'll actually put a temperature there, something of that nature, but it's always over the arrow. Okay, so you know that that reaction does not occur unless it's on a hot plate or a burner or in some sort of, in this case, 800 degrees C special oven, because that's a really hot oven. That's what the triangle means, that that reaction does not go unless it's a certain temperature. Now, the squiggle arrow over the straight arrow has something to do with radiation, and normally we're just talking about visible light or UV light. Rarely in chemistry we're going to talk about X-rays or gamma rays. For those of you that have ever had braces or something put on and they made you sit there with that weird blue light in your mouth or near your face and you had special glasses on, that was a UV lamp that was setting the plastic or the adhesive. That adhesive, that cement, does not solidify unless it has UV light on it. That is the only way that'll happen. Any medicine that comes in a dark bottle, or like hydrogen peroxide, which is in the brown bottle, it's not a brown bottle so that you can keep it straight from the alcohol. It is in a brown bottle because light will degrade it into water and oxygen gas. That's why it's in a brown bottle. All medicines that come in an opaque bottle will react with light, which is why they're in an opaque bottle. If you have a substance written over the arrow, that means it's a catalyst. Like a catalytic converter in your car has metals in it that make the bad chemicals, like the pollutants, out of the exhaust react so they're not as dangerous. Platinum is one of the chemicals that's in your catalytic converter, which is why some people try to steal them, because there are valuable metals in there. So a catalyst makes a reaction happen faster, but it does not take place or does not get used up in the reaction. Here's the parent analogy. There's always the mean parent who tells you, oh, you gotta go clean your room, or you and your sibling have been tasked to go clean the garage, and you're messing around, you're not doing something, or you're poking each other, or having a broom war in the garage, or whatever. And then all of a sudden, you hear, how's it going out there? Or you hear the door slam, and you realize that the parent is coming to check on you. And all of a sudden, stuff starts getting cleaned because that's the catalyst. The fact that the scary parent is coming to get you and you haven't gotten it done yet, that makes the reaction, the cleaning job, happen faster. The parent's not going to do the job. They're expecting you to do the job. And if it's not done, then they yell at you. Okay? So, the catalyst is the scary parent. So you get the idea. The scary parent is not doing the job. The catalyst is not doing the reaction, but they make it happen faster. The enzymes in your spit help you dissolve and react, or not dissolve, but start breaking down food so that you can eat it and metabolize it better. There are enzymes in your saliva that do that. Those are catalysts. All right, we will pick up here on Wednesday.